have to solve chi-squared test, and to do that you need a formula, and the formula is x squared e equals sigma times oi minus ei times the power of 2, and that is all over ei. Sigma in this case means sum, and the O means the number of observed data, and the E means the expected data, the numbers of expected data. Also, you need to know the null hypothesis, and that means that there is no significant difference between the observed and expected frequencies. Another thing you need to know to solve these problems, the chi-squared, is the degrees of freedom and the critical values. To get your degree of freedom, you get the number of outcomes and you subtract it by 1. In this case, there's 2 outcomes. You'll be seeing in a moment that there's 2 outcomes, and I subtracted by 1, and so you would use 2.706. So the example I came up with was you have 40 blue and brown-eyed female dogs. So you make your chart, you have your blue and your brown, and E stands for expected, so your expected is half and half, so 20 and 20. And then by using a quarter, I flip 40 times, and what the observed is 16 blue and 24 brown. So then you can start plugging into your formula. So again, your formula is this. You can see x squared E equals sigma times oi minus ei times power of 2 all over ei. Because sigma means sum, you add it and do it twice. You can plug it in 16 minus 20 squared all over 20 plus 24 minus 20 squared all over 20. When you solve that, you get 16 over 20, same as this side. Then when you simplify that, you get 4 over 5, same as this, 4 over 5. When you add them together, it equals 8 over 5. And you simplify even more, that equals 1.6. And then if you go back to your critical values and your degrees of freedom, it has to be less than 2.706 for it can be correct. If it's over, it means something went wrong in the... So, as you can see, 1.6 is less than 2.706, so that means it is correct.